Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ikram bin Zaidi. I'm from UNIZA, taking course of Bachelor in Computer Science, Network Security from Faculty of Informatics and Computing. My matrix number is BTBL 19056870 and my supervisors for this final year project is Madam Raja Hashifah binti Raja Bongsu. So the proposed final year projects is performance analysis of OLSR protocol with modified OLSR protocol in mobile ad hoc network or MANET using NS2 simulator. So I will be presenting a brief introduction about my final year projects in this video. A brief introduction of abstracts. Mobile ad hoc networks or MANETs are mobile nodes that is connected via wireless connection. So MANET is a network with no stable topology since the nodes constantly move from one location to another location. However, due to the mobile nodes that change their physical location by moving around, the network topology may change unpredictably, resulting in the difficulty of routing. Hence, routing algorithms have been used to route packets between nodes. On these projects, it will focus on the OLSR protocol, which is a proactive routing protocol. The performance of OLSR routing protocol will be evaluated as comparing it with a modified OLSR routing protocol. The objective for this final year project is to study the simulation model of MANET with an implemented OLSR routing protocol. The second objective is to implement the modified version of OLSR routing protocol in MANET using NS2 simulator. And the third objective is to compare the performance metrics of the modified version of OLSR routing protocol with a standard OLSR routing protocol. Problem statement. So the constant changes on the movement of mobile nodes in the MANET network environment lead to the unpredictable changes of network topology. So this will result in the difficulty of routing. So the existing OLSR protocol are implemented, but it still suffers from a low bandwidth and throughput. As we can see here, this is the framework. So first of all, will be the MANET implementation in the NS2 simulator. And the second one is the implementation of the OLSR protocol in the MANET itself. By this implementation of OLSR protocol, the standard OLSR protocol will be implemented as well as the modified version of OLSR protocol. And the next one is the routing selection sim. This is where the number of mobile nodes and the speed of the mobile node speed will be defined at here. And the last one is the evaluation of the performance matrix between the standard OLSR protocol and the modified version OLSR protocol. The performance matrix that will be evaluated is packet delivery ratio, average throughput, and also average delay. We will be moving on through the demo of the mobile ad hoc network environment in the NS2 simulator. For this final year project, this simulation will be run in Ubuntu 20.04 since it is compatible with the newest version of NS2, which is NS2.35. So NS2 is patched in the Ubuntu 20.04. We can simply get the file from the sourceforceget.net and search NS2 NAM file. The latest version is NS2.35 since NS2.35 is the compatible version to run the simulation for my project. And after that, simply just patch the file and update our terminal, and we can check whether the network simulation can run or not by simply enter the command ns, and this here shows that the network simulation can run successfully. There is no network simulation that are running since there is no TCL file that have to be run. So after that, OLSR will be implemented in NS2.35 since NS2.35 doesn't have any OLSR routing protocol, TCL script, or any example, since NS2.35 only have AODV, DSR, and DSDV. As we can see here, there is OLSR file in here since I have patched it before for this project. For OLSR routing protocol, I will be using UMOLSR since most of the researchers from my literature review use UMOLSR as the standard OLSR routing protocol. You simply get the OLSR routing protocol from UMOLSR in SourceForge also. Just download it and then we can patch it in the NS2 all-in-one 2.35. To check whether the OLSR file can be run or not, just simply run a example script of the OLSR. From here, for this project, I have my OLSR example. Simply ns standard olsr.tcl file, then click enter. The number of node is set for 20 and the network simulation will be run. If there is an error, it will show errors on which line that is cannot be run. So after the simulation is done, the network simulation will be exit, and a trace file and NAM or network animator file will be generated. For this trace file, it is used to calculate the performance matrix. So we will be using these trace files to compare the performance matrix of the standard OLSR TCL file between the modified version of OLSR. Network animator file can be run by entering the code NAM and the example OLSR file .NAM file. Network animator will be pop up, and as we can see here, this is the network animator for the OLSR example file. After downloading and patching the standard OLSR TCL file, we need to compare the performance matrix of the standard OLSR file with a modified version of OLSR. So, in order to do this, the standard OLSR TCL file will be need to modify into a better version of it. So here is the three others of OLSR protocol routing file that is modified. OLSR is stand for minimum loss OLSR. MD OLSR is stand for minimum delay OLSR, and ETS OLSR is stand for expected transmission count OLSR. So this file here have been altered and modified so that it can perform better than the standard OLSR TCL file. How do we alter the standard OLSR TCL file into a modified version of OLSR TCL file? So this is the standard OLSR TCL file. So I will be opening the MD OLSR and ETX. Since for these projects, I will be comparing between these two between these two TCL files. As we can see here, this is where the code to control the OLSR behavior from this script. There is a bit of difference, which is the MPR algorithm for MD OLSR is set for 2. Routing algorithm is set for 2 and link quality is set for 2, comparing by the standard OLSR TCL file. And the link delay is set for true, while the standard are set for false. For ETS file behavior is a bit different, with the MPR algorithm are set for 2, routing algorithm the same, and the link quality are also the same, reset by 2. The link delay are still false since this is an ETS file and not a minimum delay file. The difference between the ETS file and minimum delay file are there is only a link delay, which is the ETS files are set for false and minimum delay are set for true. So for standard OLSR TCL file or OLSR environment in MANET, we can set the simulation environment after setting up the OLSR modified version and the standard OLSR TCL file. So the network environment that will be used is only 20 mobile nodes. The simulation area are set for 1,000 of X coordinate and 1,000 for Y coordinates. The mobility model are set for random waypoint. Routing protocol that is used are OLSR. The speed for the mobile nodes can be set here, which is 30. But for these projects, I will be proposing on using 5 different type of speed, which is 10, 15, 20, 25, and 30 to make a brief average comparisons between the standard and the modified version of OLSR. The simulation time limit is set for 100. The max number for simulation time limit is 900, but it will take a too long times for the simulation to run. And the traffics that is used for this simulation are CBR or constant bit rate, and the packet size are set for 512. As we can see here, the traffic is set for CBR or constant bit rate. The packet size are set for 512. This simulation will be run for at least 3 times to get the average throughput, packet delivery ratio, and end-to-end delay. Just simply run the N as standard OLSR.tcl. It will take some time since it differs for machines that use virtual machine and a fully OS version. And then we run for the MDTCS script. After running the simulation for MD OLSR TCS script, we will run the ETX OLSR TCS script. There is no error since the network simulation are done. So we can see here there is a trace file for the standard, DMD trace file, and the ETX trace file. So by this time, we can calculate their average throughput for the trace file. How do we calculate it? This is the AWK file to calculate the throughput and average delay. For average delay, packet delivery ratio are needed to calculate average delay. So the calculation for average delay are set inside the average delay AWK file. Just simply get AWK file and enter which file that we want. So this will be the throughput, and after that, the trace file that we want to calculate. I will be using tr throughput. After that, the AWK of delay. So as we can see here, the throughput for the trace file for standard OLSR is 70.9581. The average end-to-end delay is 3257 millisecond, and the packet delivery ratio are 20.794%. We can simply enter the same command for the other trace file, which is the MD trace file, throughput and delay. As well as the throughput and delay for ETS file. So we have managed to get the throughput end-to-end delay for these three type of OLSR file, which is the MD standard and ETS file. The results are also different, but then this is only the first simulation that we run. So we need to run at least 2 times, at least 3 times, so we can get an average data of the OLSR between the standard and the modified version. After running this simulation for the standard OLSR and the modified version, which is the MD and ETS OLSR, and getting their average end-to-end delay, packet delivery ratio, and also throughput, the data will be collected and will be filled in the table here. After confirming the average delay, average throughput, and packet delivery ratio in this table, so I use the information from the table to create a graph to see and to have a better understanding on the difference between the standard OLSR and the modified version of OLSR. As we can see here, so OLSR ETX have the better throughput from the standard OLSR. For average end-to-end delay, standard OLSR have the highest delay on a low mobility speed, but then ETX maintains its performance by simply have the average lowest delay in the simulation. Next is packet delivery ratio. As we can see here, OLSR ETX have the highest packet delivery ratio than the standard OLSR. From those results that I get, so I can conclude that the modified version of OLSR protocol outperform the standard OLSR protocol, since the standard OLSR protocols suffer from low bandwidth and throughput. The modified version have a better average throughputs and also average end-to-end delay and packet delivery ratio than the standard OLSR protocol. For my contribution, I have successfully implemented the modified version of OLSR in a MANET environment, and also figuring out which version of OLSR perform better in terms of different mobility speed in a MANET network environment. So that's all from me. Thank you.